Hi everyone. In this video, we will be talking about the math class, basically the operations that are available through using the Java math class. The learning objective covered by math class is 11. Define and write code using basic methods for the math class, which includes absolute value, min, max, pow, which is like exponent, and square root. Static methods in other classes. As we have seen before, Java includes a variety of primitive data types: byte, short, int, long, float, double, char, and boolean. And we've talked about some of these data types previously. On top of that, the Java standard library includes thousands of other data types and classes. So things like system, which we've seen already with system.out.println, string, we've seen that before. There's many, many more. The math class in particular contains static methods for common mathematical operations for which an operator does not exist in Java. I mentioned before, exponent is not a basic operation or primitive operation in Java. Instead, you would need to use math.pow. So the way that you would take an exponent, you would call that method the name of the method is pow, and then in parentheses here, put your two numbers. I have math.pow 2, 5. That will give me 2 to the power 5, which is 32. I have here a slide that has a table of Java's math class. So you may use this slide as a reference, but it has the method names and then a description of what they do. For example, math.pow, which we have seen already, math.pow takes inside its parentheses a base and an exponent, and it takes base to the exponent power. So that's an example of a method that has two parameters in it. Meanwhile, something like absolute value, math.abs, inside parentheses, it just says value. It takes the absolute value of that number. So it only needs one number inside its input when you call on it. Please do take time to read out what all of these are and understand what they do. If I were to write out math.pow and then in parentheses 3, 4, semicolon, I know that the answer is 81.0, but the terminal is not going to actually print out any output for you. So the math methods do not print to the console. Each method returns a numeric results, and those results are used as expressions. So math.pow 3, 4, ending with a semicolon gives me no output, and similarly, just typing in 81.0 and ending with a semicolon does not give me any output. So take a moment to think, if I want 81 to appear on my output, how do I make it do that? So the answer to that is to use some sort of print. You can store it in a variable. So here I have double result is equal to math.pow system.out.println result. And now that will actually appear on the terminal. So if you are not seeing an answer that you are expecting to see on your terminal, make sure it's actually printing things out. I already mentioned that the way that you call math methods is capital M math dot whatever your method is, and then in parentheses parameters. I have here some examples to showcase that a little bit more. The first example I have is square root math.sqrt inside parentheses 121.0. So when you print that out, it will give you 11.0. So notice here for both math.sqrt and math.abs or abs, you only put in one parameter because those are math operations that only need one parameter. On the other hand, math.min requires at least two parameters, so I'm taking the minimum of the numbers 3 and 7 in this example. I have math.min 3, 7, which will give me 3, and then I've also combined it with another expression. So I have 3 plus 2, which will give me 5. So you can simplify these operations step by step. You can actually trace what the output will be. Now, math methods return rather than print. Return means to send out a value as the result of a method. It's the opposite of a parameter. Parameter is the number that you would write in there. For example, if I have math.abs negative 42, the parameter is negative 42. The parameters send information in from the caller to the method. So main is actually calling math.abs, and so it's sending in this information, negative 42. The return values send information out from a method to its caller. You might wonder, why don't math methods print their results rather than return them? The answer is basically returning is more flexible than printing, and it allows you to combine the results of many computations. I already talked about how you can combine the output of math methods with another arithmetic expression, or even combine math methods together. So for example, I could have, let's take the exponent of 3 to the 4, math.pow 3 comma 4, and 10 to the 6, math.pow 10 comma 6. Now system.out.println, I can do pow 1 plus pow 2. So it allows you to compute several things before printing, and maybe in some cases you would want to save the variable pow 1 to be used elsewhere. So that's also where it's going to be helpful. I have here a slide that just has various math questions on it. So you can take some time to pause the video, look at the slide, and try to answer what the output of these expressions should be. And as well, if you like, you may type this into your text editor and see if compiling the code you actually get the same answer. In general, it's good practice to try to make sure that you can work things out by hand, because that makes sure that you know how to do it. And then it's good to double check your work by actually putting it into the computer and then compiling it and running it to see if it matched what you expected. And then if it doesn't, you know, either something in your logic is wrong or something in the way that you coded it is wrong. Great. So these are just some straightforward math questions, just basically figure out what each of these expressions do. I have one more slightly more complicated problem. Math.max and math.min can be used to bound numbers. If I had an int variable named age, what statement would replace negative ages with 0? And what statement would cap the maximum age to 40? So that's something that would take a little bit more effort on your part to try to understand how to do, but please feel free to pause the video or come back to this to try and answer these questions. There are a couple things to be wary of as we are using math class or even doing basic arithmetic operations. For example, some math methods return double or other non-int types. You might expect math.pow to return an int. If I just do 10 to the 3, then I know that I should be getting 1,000, so that should just be an int, right? But that's not going to be the case. So you're going to get an error if you try to say int x is equal to math.pow 10, 3, because that type is not the type of math.pow. Now, another problem is if you are expecting double values, you might get more digits than you really want. So for example, if you did 1 divided by 3, 1.0 divided by 3.0, okay, I've set it as a result, everything should be fine, but the system.out.println result is 0.3333, just repeating as many times as it kind of wants to. And that might not be the kind of output that you want either. So usually for that, if you want it to print out 0.3 just one time, something like that, you would have to make sure to use the formatting strings properly. Now, really the trouble is the computer represents doubles in an imprecise way. You might find if I type in system.out.println 0.1 plus 0.2, the output is actually 0.3, bunch of zeros, and then a 4. So this has to do with the fact that computers have only a certain level of precision associated with them. And so you can't actually do what you consider to be math on the real numbers. You are only working with certain precisions, and because of the way that that's done, you might end up with doubles that are imprecise. One thing you might have noticed is I've been saying this word static. So learning objective 21 actually talks about explaining static methods. You should be able to write a static method, define and write a method header with parameters and with return type and value. We're not going to go into the details of everything that has to do with static methods, but since I'm starting to mention it, I thought I would point out that one of the learning objectives covered here is also 21. I want to talk about returning a value from a method. We've already seen an example in math.pow. So math has a method associated to it called pow that returns a double. So the way that you would write your own methods using this example, public static, the type is double, that's the return type, the name is pow. And then inside you're going to put your parameters. Math.pow takes in 2 ints or maybe 2 doubles. And so you would actually write those 2 things in, giving them some sort of variable name. Then you're going to have whatever logical statements you want on the inside, and then you're going to return the final expression. Good. Now, let's look at a particular example that you can also take a moment to try and write by yourself in your text editor. The example that I want to talk about is returning the slope of the line between 2 given points. Okay, so whenever you want, take a moment to try this out yourself, but let's work through it by hand. How would you normally take the slope between 2 points? Okay, well, points are usually given as something like x1, y1, and x2, y2, and I know that I need to do basically the difference between the y's and divided by the difference in the x's. So that's rise over run. Great. So I know that I want to type out public static, probably double, slope, and I have 4 parameters, which are x1, y1, x2, and y2. So this is what this looks like. Public static double slope, int x1, int y1, int x2, int y2. So I'm giving names to all the parameters with these variable names. Then inside, I'm just doing double dy is equal to y2 minus y1, and double dx is equal to x2 minus x1. Return dy over dx. So let's just double check this example against the skeleton that I have above. I said you needed a type, and this does have a type. It's double. So good, I have a return type. The name, I've given it a name, which is slope. So that's also good. I'm so far matching things. And then parameters is a little bit tricky. I think you have to remember to give your variables names, and you have to specify the type of each of those variables. So x1, x2, y1, and y2 are all ints. So these parameters have to also include that type name in front of that. Then I have code on the inside. We've written things like this in the main method before, but I have double dy is equal to y2 minus y1, double dx is equal to x2 minus x1. Great, and so those are going to return double, and I can return dy divided by dx. I will leave you with a question here, which is, why am I assured that even though x1 up to y2 are all ints, that the answer that I'm going to get is actually going to be a double? Why don't I have any problems with integer division here? But I'll leave that with you to think about. Let's do a little bit of practice. Here's a question for you. What is output by the following code? take a moment to pause the video and try to answer this on your own. Work it out, and then if you would like, you may also put it into your text editor and compile to see if the console prints out the same thing that you are expecting. Okay, so let's start working out what's happening in the system.out.print. I start by noticing that I have some plus signs here. I have 4 of those. And I might think, great, I'm adding together certain math operations, so some expressions. But then I notice that furthermore, I have these quotation marks. So with quotation marks, I'm actually doing a string, and it actually means that I'm concatenating different things together. So with these 4 plus signs that are separated by spaces, I notice that I must actually have 1, 2, 3 numbers that the system.out.print should give me. So the answer A is actually out because it just adds the numbers together. But it looks like all of the other ones print out 3 different numbers, so they're still okay to possibly be the answer. Continuing on, I think the easiest thing on here is to just look at A, the very last thing in the string, which doesn't have any math operation associated to it. So A is negative 1.9. If I look at my answers, I want to ensure that the last number printed out to the console is negative 1.9. So B is gone because the last number is negative 2.0. C is gone, and it looks like D and E are still good to go. Now we need to understand how both math.floor and math.ceil work. Math.ceil rounds a number up. So math.ceil of B is 2.25, so it will be 3. One thing I don't know off the top of my head, though, might be, is it going to give me 3, the integer, or is it going to give me 3.0 as a double? You can check the Java library to see which one of those it is, but for now, I'm not sure, D or E. Continuing on, though, can I find out something more with math.floor of A? Well, math.floor rounds a number down. And since this is a negative number, I know that negative 1.9 is between negative 2 and negative 1. So rounding down, I know it's going to be negative 2. And looking at these answers, that actually tells me D is not the answer because it gives me negative 1. So the answer will be E, negative 2.0, 3.0, and negative 1.9. This is just one way to trace the solution. There are obviously other ways to go about doing this. You could have just gone in order if it made sense to you, but this is one way of doing process of elimination for these kinds of multiple choice questions. For this practice problem, I have given you a code snippet, which you can basically think of as being in 2 pieces. The first is I have int x is equal to 5, int y is equal to 7, and then I have this output of m of x comma y and m of y comma x. And I'm going to print those out. M itself is a method which is listed down here, and it takes in 2 parameters, int a and int b. It adds 2 to a, it subtracts 2 from b, and then it returns a times b. So take a moment, you can pause the video, trace the code, and try to see what it will do by hand. Once you have done that, take a moment to type it into your text editor and actually run it and see if it matches what you expected. Now, notice that this is just a code snippet, not the whole code. So if you just copy paste what I have here, it will not run. You need to make sure to type in a main and a class. And once you do that, you should be able to run the code. I've asked you to name the class Math Practice. Okay, so we'll pause for a second, and then we will try to answer this question. Great. So probably a lot of people might have thought that it was going to be 35, 35, but the answer is actually 35, 27. So let's watch and figure out why this is. Well, first of all, I'm going to declare x and y in the very first two lines, and x is 5 and y is 7. Now, when I do output 1 mxy, I look inside my method and I see a plus equals 2, so that's the one associated to x because it came first in the arguments, so mx, that's why, and int a. And so that's going to change x from 5 to being 7, so it adds 2. Now, for b, it does b minus equals 2, so that's the one associated to y, so y is going to be 5. And I know 7 times 5 is 35. Good. Now, it seems like when I do m of yx, I'm just swapping these around. So y is starting out as being 5, and x is starting out as being 7. So the same thing should happen, and it should give me 35 again. But that is not the case. This call is actually just going to take the original values of x and y, which were 5 and 7, and now x is going to have 2 subtracted from it, so it's 3, and y is going to have 2 added to it, which is 9. So the answer that you actually get for this is 27. So when you call these two methods, you have to be careful about where the call stack is, but these are actually two separate processes. Let me just leave you off with the learning objectives that we covered. Most of it was 11, define and write code using basic methods for the math class. However, we also spent some time explaining static methods, and we showed how to write a static method with a method header and parameters and with a return type and value. That's all I have for this, so thanks for watching.